The year is 1944, Normandy. A Sherman tank commander named Lieutenant Paul Kern sits frozen in his turret, watching through his periscope as his gunner frantically works the breech. They have just fired at a German Panther. They missed. The Panther did not miss. The shot punched through the Sherman next to them 3 seconds ago, now that Panther is traversing its gun toward Kern's tank. His gunner is reloading, hands shaking, dropping the shell, picking it up, ramming it home. 8 seconds, 9 seconds. The Panther's gun is almost locked on. 10 seconds, 11. Finally, the breech closes. They fire. They miss again. The Panther fires. This time, Kern's Sherman erupts in flames. He has 4 seconds to get out before the ammunition cooks off. In that moment, crawling through smoke and heat, he understands something that will haunt him for the rest of his life. The Sherman's single greatest weakness was not its armor, not its gun, but time itself. Every reload was a window where death could arrive uninvited. This is the story of how one mechanic, dismissed as crazy by his superiors, found a way to close that window. But it is really about the desperation that drives innovation, when you are outgunned, outmatched, and watching your friends burn, and what it reveals about the thin line between genius and madness when survival demands the impossible. June 1944. The Allied invasion of Normandy has been underway for 3 weeks. On paper, it is succeeding. Thousands of troops are ashore. Supply lines are holding. The German army is being pushed back, slowly, bloodily, field by field. But inside the American armored divisions, a darker truth is taking shape. The Sherman tank, which had seemed so formidable in training, so modern and reliable compared to anything that came before, is being systematically slaughtered by German armor. Not occasionally, not in isolated incidents, systematically. Every encounter with a Panther or Tiger tank follows the same horrifying pattern. The Sherman fires first. Its shell bounces off the German armor or merely scratches it, and then the German tank fires once and the Sherman explodes. The crews have started calling their vehicles Ronsons, after the cigarette lighter company whose slogan was "Lights every time." Dark humor. The kind that keeps you functional when the alternative is paralysis. But underneath the jokes, there is a growing certainty that they are being sent into battle in machines that cannot win the fight they are being asked to fight. The Sherman was designed for a different war, a war of mobility and exploitation, where speed and reliability mattered more than armor and firepower. It was built to swarm, to outmaneuver, to overwhelm through numbers and industrial might. But here in the hedgerows of Normandy, where sightlines are measured in dozens of meters and every field is a potential ambush, none of those advantages mean anything. What matters is the first shot, and if the first shot does not kill, what matters is the second shot. And the Sherman's second shot takes too long. In a maintenance depot 5 miles behind the front lines, Staff Sergeant Curtis Cullen is watching another burned-out Sherman get towed in. He is a mechanic, a Tennessee boy who grew up taking apart tractors and farming equipment, the kind of man who understands machines, not through manuals but through intuition, through the feel of metal and the sound of engines. He has been watching Shermans come back from the line for 3 weeks now, and he is starting to see patterns. Most of the destroyed tanks have been hit while their crews were reloading. The evidence is there in the positions of the bodies, in the shells scattered inside the turrets, in the breech mechanisms frozen half open. The math is brutal and simple. It takes a well-trained Sherman crew approximately 12 seconds to reload the 75mm main gun. In combat, with adrenaline and fear and smoke filling the turret, it takes longer. 15 seconds, sometimes 20. A German Panther can reload in 7 seconds, a Tiger in 8. That gap, that 5 to 12-second window, is where American tank crews are dying. Cullen cannot change the Sherman's armor. He cannot make its gun more powerful. But maybe, he thinks, maybe he can do something about time. The idea comes to him while watching a crew train on a replacement Sherman. The loader is good, fast, efficient. But there is a moment every single time where he has to wait for the gunner to confirm the shot, wait for the breech to open, wait for the spent shell casing to be ejected, and then reach for the next round. 2 seconds, 3 seconds. Not much, but in those 2 or 3 seconds, the entire crew is helpless. The tank cannot fire. It cannot maneuver effectively because the gunner's attention is divided. It is simply a target waiting for the enemy to aim. What if, Cullen wonders, you could eliminate that wait? What if the next shell was already positioned, ready to load the instant the breach opened? The problem is physics and geometry. The inside of a Sherman turret is cramped. The main gun's breech mechanism is massive, and when it recoils, it takes up space. The loader stands to the left of the gun, reaching down to the ready rack where shells are stored. Pulling one out, lifting it, aligning it with the breech and ramming it home. Every step is necessary. Every step takes time. But what if you could bypass some of those steps? Cullen starts experimenting. He takes sections of metal pipe, the kind used for plumbing in field latrines, and begins bending them, cutting them, welding them together. The other mechanics think he has lost his mind. They watch him crouched beside a Sherman, holding pieces of pipe up to the turret, muttering to himself, taking measurements with a piece of string and a ruler. One of them asks what he is doing. Cullen does not answer directly. He just keeps working. After 2 days, he has something that looks less like a machine part and more like abstract sculpture. A curved metal tube, roughly 3 inches in diameter, running from a point near the ready rack up and around the gun breech, ending just behind the loading position. It looks ridiculous. It looks like something a child might build out of scrap. But Cullen knows something the others do not. Geometry can be more powerful than horsepower. Angles can beat armor. And time, even a second of time, can mean the difference between survival and cremation. He installs his contraption on a training Sherman without asking permission, because he knows if he asks, the answer will be no. Officers do not like unofficial modifications. They like standardization, predictability, systems that have been tested and approved by people with engineering degrees. Cullen has a high school education and a toolbox. By military standards, he is nobody. But the crews who have been coming back from the line, the ones who survived, they are willing to try anything. Cullen gathers a tank crew and explains his idea. The curved pipe, he tells them, is a shell guide. The loader places a shell into the top of the pipe immediately after firing, before the breech even opens. The shell slides down through the curve, held in position by gravity and the shape of the tube, and emerges at the bottom directly in line with the breech. The instant the breech opens and the spent casing ejects, the loader simply pushes the shell forward. It is already aligned, it is already positioned. No reaching, no lifting, no fumbling. Just push. The crew looks skeptical. One of them points out that the shells weigh nearly 20 pounds. Will they slide smoothly through a metal pipe? What if they get stuck? What if the pipe bends under repeated use? Cullen does not have answers to these questions. He has a theory. And the only way to test a theory is to try it. They run drills. The first attempt is clumsy. The loader drops the shell into the pipe too hard, and it jams halfway down. They clear it, adjust the angle, try again. This time the shell slides through, but it comes out crooked, and the loader has to adjust it manually before ramming it home. They are not saving any time. They are losing time. The crew is ready to quit. Cullen is not. He spends that night adjusting the pipe, smoothing the interior with files and sandpaper, changing the curve by a few degrees. The next morning they try again. This time the shell slides through cleanly. The loader catches it at the bottom, pushes it into the breech. The breech closes. Cullen checks his stopwatch. 7 seconds from firing to ready to fire again. They try it again. 6 seconds. Again. 5 seconds. The crew stops talking. They stop joking. They are staring at the pipe contraption like it is a religious artifact, because what Cullen has done with plumbing supplies and intuition is cut the Sherman's reload time in half, maybe more. Suddenly the Panther's advantage is not 7 seconds versus 12, it is 7 seconds versus 5. Suddenly the Sherman crew has a chance. Word spreads, not through official channels, through the network that exists in every army, the invisible web of enlisted men who talk to each other in mess tents and repair depots and aid stations. A sergeant mentions it to a lieutenant. The lieutenant mentions it to a captain. Within a week, tank crews are showing up at Cullen's depot asking for the pipe. He builds them by hand, each one custom fitted to a specific Sherman, because no 2 tanks are exactly identical after weeks of field use. He works 18-hour days, welding and grinding and measuring. Officers start to notice. Some of them are intrigued, others are furious. There are regulations about unauthorized modifications. There are procedures for testing new equipment. There are chains of command. Colin has ignored all of them. A colonel arrives at the depot and demands to see this miracle pipe he has been hearing about. Colin shows him. The colonel watches a demonstration. 6-second reload, 5 seconds, 4.8 seconds on the last run, with a crew that has been practicing for only 2 days. The colonel does not smile. He does not congratulate Colin. He asks a single question. Does it work in combat? Nobody knows. The crews who have the pipes have not been back to the front yet. The modification is too new. So the colonel makes a decision. He orders 5 Shermans equipped with Colin's pipe, sent to a company that is moving up to the line the next morning. They will be the test. If the pipes work, if they provide a real advantage, the modification will be approved and manufactured properly. If they fail, if they cause malfunctions, or slow the crews down or get men killed, Colin will face court-martial for reckless endangerment. The stakes are now absolute. Colin has built something that might save lives or might end his career and possibly his freedom. He has no control over the outcome. All he can do is wait. The 5 Shermans with the loading pipes move into position near the village of St. Lo. It is mid-July now, and the battle for Normandy has become a grinding nightmare of attrition. Every hedgerow hides German infantry. Every tree line might conceal a panther. The crews are exhausted, hollow-eyed, hollow, functioning on adrenaline and caffeine, and the fear that if they stop moving, they will start thinking about the friends who are not there anymore. One of the Shermans with Colin's pipe is commanded by Lieutenant Kern, the same officer who barely escaped his burning tank 3 weeks earlier. He has been given a replacement Sherman and a replacement crew, all of them fresh from England. All of them terrified because they have heard the stories. Kern does not tell them about the pipe at first. He does not want to give them false hope. He has seen too many miracle solutions that turned out to be nothing. But his loader, a kid from Ohio named Private Danny Wojcik, notices the metal tube and asks what it is. Kern explains. Wojcik listens, nods, says nothing. That night, before they move out, Kern hears Wojcik in the turret practicing, loading a dummy round into the pipe, letting it slide down, catching it, pushing it into the breach, over and over, the sound of metal on metal in the darkness, preparation, ritual, prayer. The attack begins at dawn. The objective is a small ridge overlooking a crossroads. Intelligence reports suggest light opposition. Intelligence is wrong. The Shermans advance across an open field, and German guns open up from the tree line 300 meters away. Not machine guns, not mortars, tank guns. 2 Panthers, hull down, perfectly positioned. The first Sherman in line takes a hit immediately, bruise up in seconds. The other Shermans scatter, trying to find cover in terrain that has none. Kern's tank slides into a shallow depression, just deep enough to hide the lower hull. He can see one of the Panthers through his periscope. The Panther can see him. This is the moment. The loader, Wojcik, already has a shell in the pipe. The gunner acquires the target. Kern gives the order. They fire. The shot hits the Panther's turret, does not penetrate, but the impact disorients the German crew for a moment. That moment is all they have. Wojcik drops another shell into the pipe. It slides down. He catches it, rams it home. The breach closes. 4 seconds. The Panther is traversing back toward them. Kern orders fire. They hit the Panther again, same spot, turret front. Still no penetration, but now there is smoke. The Panther's gun is almost aimed at them. Wojcik loads again, 3.6 seconds, they fire. This time the shell hits lower, catches the join between turret and hull, punches through. The Panther lurches, stops moving. Smoke pours from the hatches. Kern does not have time to process what just happened. The second Panther is firing now, hitting the Sherman to their right. That tank explodes. Kern traverses toward the second Panther. It is farther away, 500 meters, a difficult shot. They fire. Miss. Wojcik loads. 4 seconds. Fire. Miss again, but close. The Panther is turning to face them now. This is it. If they miss the next shot, they die. Wojcik loads. 3.8 seconds. The gunner takes a breath, adjusts, fires. The shell crosses 500 meters in less than a second and hits the Panther's front glacis at an angle, skips upward, slams into the gun mantlet, and penetrates. The Panther shudders, and then its ammunition cooks off. The turret lifts into the air, flips, crashes down 20 feet away. Silence. Kern realizes he has been holding his breath. Around him, the crew is shaking. Wojciech is staring at the loading pipe like he cannot believe it is real. They have just killed 2 Panthers, 2, in less than a minute, with a Sherman. It should not have been possible. But the math does not lie. They fired 8 rounds in the time it would normally have taken to fire 4. Those extra shots, that extra time, made the difference between winning and dying. When they return to the depot that evening, Kulin is waiting. He does not ask how the pipes worked. He can see it in their faces. Kern walks up to him, and for a moment he does not say anything. Then he grabs Kulin's hand and shakes it, hard, and says, "Thank you." Just that. Thank you. Other crews come back with similar stories. Not all of them won their engagements, because the pipe was not magic. It could not change physics or make Sherman armor thicker. But it gave them a chance. It gave them seconds, and seconds were everything. Within a week, every Sherman in the division is being retrofitted. Engineers arrive from the rear, studying Kulin's design, trying to standardize it, mass-produce it. They make changes, improve the metallurgy, adjust the curves based on mathematical models. The final version is more elegant than Kulin's original, more durable, more refined. But the concept is his. The desperation that drove it is his. The willingness to ignore regulations and risk everything on an idea is his. By August, the modification has spread to other divisions. By September, it is standard issue for new Shermans rolling off the factory line in Detroit. Somewhere in the bureaucratic process, it stops being called Kulin's pipe and starts being referred to as the Rapid Reload Assembly. Official, sanitized, the kind of name that erases the individual and credits the institution. But the crews know. They still call it Kulin's pipe, or just the pipe, or sometimes the crazy pipe, because it looked crazy, and the man who invented it acted crazy. And the whole idea seemed crazy until it worked. This is how innovation happens in war. Not in laboratories, not in planning committees, in the field, under fire, by people who are desperate enough to try things that sound insane because the alternative is accepting death as inevitable. But here is where the story becomes something more than a tale of clever engineering. Because the pipe did not just change reload times, it changed psychology. Before the pipe, Sherman crews went into battle knowing they were outmatched, knowing that if they encountered German heavy armor, their best hope was to run or to swarm the enemy with numbers and accept catastrophic losses. That knowledge affected everything: how they moved, how they fought, how they thought about their own survival. It created a feedback loop of fear and hesitation. After the pipe, something shifted. Not completely. The Sherman was still objectively inferior to the Panther in armor and firepower. But now there was a variable the Germans had not accounted for. Now there was a moment of doubt in the minds of Panther commanders who expected a 12-second window between Sherman shots and instead got 4 seconds. War is mathematics, but it is also psychology. Confidence matters. Momentum matters. The belief that you can win matters. And Kulin's pipe, a piece of bent metal tubing that cost almost nothing to manufacture, gave Sherman crews something they had lost in the hedgerows of June: the belief that they could fight back. The German response is instructive. When reports reach Wehrmacht command that American Shermans are firing faster, the initial reaction is dismissal. It is impossible, they say. The Sherman's loading system is known. Its limitations are fixed. What the forward units are experiencing must be explained by other factors. Green crews panicking, exaggerated reports, coordination with tank destroyers being mistaken for rapid fire from a single tank. But the reports keep coming. And eventually, captured Shermans are examined. The pipe is discovered. German engineers study it, photograph it, write reports. Their conclusion: it is a crude field modification that should not work as well as it does, but empirical evidence suggests it reduces reload time by 40 to 50%. They recommend a similar modification for German tanks. The recommendation is rejected, not because the idea is bad, But because the German war machine in late 1944 is not capable of improvisation at scale, their production systems are too rigid, their chains of command too hierarchical, their resources too strained. They have built an ideology around precision and planning and supremacy, and when an enemy solves a problem with a piece of pipe and intuition, they cannot adapt because adaptation requires admitting that their approach might be flawed. This is the gap between doctrine and reality, between the war you planned for and the war you are fighting. There is a deeper irony here, one that goes beyond tactics and technology. The Sherman tank, which has become a symbol of American industrial might, was never intended to be the best tank in the world. It was intended to be good enough, cheap enough, and mass-producible enough to overwhelm the enemy through sheer numbers. It was a manifestation of American pragmatism. Build something that works, build it fast, build it in quantity, and iterate in the field. The Germans, by contrast, built the Panther and Tiger to be the best tanks in the world. They succeeded. But they could not build them fast enough, could not keep them supplied, could not replace them when they were lost. So the question becomes, what is better? The perfect weapon you cannot replace, or the adequate weapon you can build by the thousands and improve with bent pipe? History provided an answer, but the men inside those adequate weapons, the men who burned when the first shot failed, they deserved better than adequacy. Cullen understood this. He could not make the Sherman into a Tiger, but he could give the crews inside a few extra seconds to make their adequacy count. After the war, Curtis Cullen returns to Tennessee. He does not talk much about the pipe. He goes back to fixing tractors and farming equipment, living a quiet life, largely unknown outside his community. The Army gives him a commendation, a piece of paper that says his contribution was valued. He frames it, puts it in a drawer, rarely looks at it. In interviews years later, when historians track him down, he seems almost embarrassed by the attention. He insists he was just doing his job, that any mechanic could have come up with the same idea, that he got lucky. But this is the modesty of men who have seen war up close, who know that heroism and luck and timing are often indistinguishable, who understand that the gap between life and death is sometimes just a few seconds, and a willingness to try something that sounds crazy. Cullen does not see himself as an innovator. He sees himself as a man who watched his friends die and refused to accept that there was nothing he could do about it. The pipe itself becomes a historical curiosity. You can find examples in museums now, mounted next to restored Shermans, with plaques that explain its function in technical language. But the plaques do not capture what it felt like to be inside a turret, watching a Panther traverse its gun toward you, and knowing that the only thing keeping you alive was a piece of bent metal tubing and the hands of a scared kid from Ohio who practiced loading in the dark. They do not capture the desperation that drives innovation when the institution has failed you, when the equipment you have been given is not enough, when survival depends on someone, somewhere, ignoring the rules and trying something new. War creates conditions where the impossible becomes necessary, and the necessary becomes possible through sheer force of will. There is a philosophical weight to this story that extends beyond World War II, beyond tanks, beyond any specific conflict. It is about the confrontation between systems and individuals, between planning and improvisation, between the war you prepare for and the war you get. Institutions are built on the assumption that problems can be anticipated, that solutions can be designed in advance. That expertise resides at the top of hierarchies. And sometimes this is true, but sometimes the expert is a mechanic with a toolbox who sees a problem the planners missed, because he is close enough to the consequences to care deeply and personally. Sometimes the solution is not elegant or proper or approved. Sometimes it is a pipe that looks ridiculous and works anyway. This is the uncomfortable truth that institutions hate to acknowledge, that the people at the bottom, the ones actually doing the fighting or the building or the fixing, often understand the problems better than the people at the top giving orders. And when institutions are wise, they create space for those people to experiment, to fail, to try crazy things. When institutions are rigid, they crush that experimentation in the name of standardization and control, and people die because of it. The Sherman crews who survived because of Cullen's pipe did not care about institutional wisdom or proper procedures. They cared about the fact that someone, somewhere, gave enough of a damn to try to help them. That is the human core of this story, not the engineering, not the tactical advantage. The fact that one man looked at the problem of his friends burning to death and said, "No, I will not accept this. There has to be a way," and then he found a way. And the way was not perfect. It did not solve every problem. Sherman tanks still burned. American tank crews still died. The pipe did not end the war or change its outcome. But it gave some people a chance who would not have had one otherwise. It closed a gap, bought seconds, tilted a few encounters from certain death to possible survival. In a war where millions died, where entire cities were erased, where the scale of destruction numbs the mind, this feels small. But to the men in those tanks, to Wojciech loading shells in the dark, to Kern climbing out of a turret one more time instead of burning, it was everything. So what does this reveal about us, about humanity, about the gap between what we are told and what is true? It reveals that systems, no matter how well designed, will always have flaws that only become visible under stress. It reveals that expertise is not always where we expect to find it, that sometimes the person with the solution is not the one with the degrees and the rank, but the one with the proximity and the desperation. It reveals that innovation is often born from refusal, from the stubborn insistence that things do not have to be the way they are. And it reveals something darker too, that institutions will often accept preventable deaths rather than empower individuals to break the rules. The Sherman's reload problem was known before Normandy. Engineers understood it, but fixing it required admitting that the tank had a fundamental flaw, and admitting flaws threatened production schedules and morale, and the carefully constructed narrative that American equipment was good enough. So nothing was done, until Kulin did it himself, without permission, risking punishment to save strangers. This pattern repeats throughout history. Someone sees a problem, someone proposes a solution that violates norms or procedures. The institution rejects it, or ignores it, or buries it in committees. And then when the consequences become undeniable, when the bodies pile up, someone outside the system acts, and sometimes it works. And then the institution takes credit, or sanitizes the story, or erases the individual and pretends the solution came from proper channels all along. This is not cynicism. This is documentation. The rapid reload assembly was not developed by Army engineers in a laboratory. It was bent into existence by a Tennessee mechanic with a pipe cutter and a refusal to accept unnecessary death. But the official history will list it as a field modification developed in theater and subsequently standardized, which is true but incomplete. The truth is messier, more human, more uncomfortable for institutions that prefer to see themselves as rational and responsive. And here is the final weight of it. You cannot build a system that anticipates every Curtis Kulin. You cannot institutionalize desperation or bureaucratize genius or plan for the innovations that come from the edges. What you can do is create space for them. What you can do is listen when the people closest to the problem say there is a better way. What you can do is value adaptability over rigidity, results over procedure, survival over protocol. The armies that do this, the institutions that do this, the societies that do this, they survive. The ones that do not, that insist on control and hierarchy, and the fiction that wisdom flows only downward, they calcify and break. This is not just a lesson about tanks in 1944. This is a lesson about how humans solve problems under pressure, about where innovation comes from, about the cost of ignoring the people who see the problems because they are living them. Curtis Kulin bent some pipes together and saved lives. That is the surface story. The deeper story is about what happens when someone refuses to accept that death is inevitable. When someone decides that the gap between what is and what could be is worth crossing even if it means risking everything. That refusal, that willingness to act when action is not authorized or expected or safe, that is where change comes from. Not from committees, not from plans, from individuals who see clearly and care enough to try. The pipe worked because Cullen understood geometry and physics, yes, but it existed because he understood something more fundamental. That every second mattered, that every life mattered, that the difference between tragedy and survival was often just someone caring enough to try something crazy. And in a world that constantly tells us to stay in our lane, to follow procedures, to trust the system, That might be the most radical thing of all. To look at a problem, to see a solution, and to build it with your own hands, even when no one gave you permission. That is what Cullen did. That is what the men in those tanks benefited from. And that is what we should remember when we think about how humans survive impossible situations. Not through perfection, not through planning, but through improvisation, desperation, and the stubborn refusal to let others die when there might be another way.